Python library and deep neural networks, DNN, relationship. Pradeep K. Suri. Author and researcher. Python has become the de facto programming language for working with deep neural networks, DNNs, and artificial neural networks in general. The relationship between Python and DNNs is closely intertwined because Python provides a rich ecosystem of libraries and tools that make it easier to develop, train, and deploy DNN models. Here's how Python and DNNs are related. 1. Libraries and frameworks. Python has several powerful libraries and frameworks, as mentioned in the previous response, that are specifically designed for deep learning and neural networks. These libraries, such as TensorFlow, PyTorch, Keras, and more, are implemented in Python and provide the tools and infrastructure necessary to work with DNNs. 2. Ease of use. Python is known for its simplicity and readability, which makes it an ideal language for both beginners and experienced developers to work with DNNs. The clean and intuitive syntax of Python facilitates quick prototyping and experimentation with neural network architectures. 3. Data science ecosystem. Python boasts a rich ecosystem of data science and machine learning libraries, including NumPy, SciPy, Pandas, and scikit-learn. These libraries complement the deep learning frameworks by providing data manipulation, analysis, and pre-processing capabilities, which are essential for working with DNNs. 4. Community and resources. Python has a vast and active community of data scientists, researchers, and developers working on DNNs. This community support is valuable for sharing knowledge, seeking help, and accessing a wide range of pre-built models and resources, including tutorials, documentation, and open-source projects. 5. Visualization and tools. Python offers various visualization libraries like Matplotlib, Seaborn, and Plotly, which help in visualizing and understanding the results and behavior of DNN models. Additionally, Jupyter Notebooks, a popular Python tool, provides an interactive environment that is widely used for documenting and sharing DNN experiments. 6. Deployment. While Python is excellent for prototyping and development, it's also possible to deploy DNN models in production systems using various deployment tools and platforms. Many of these deployment tools allow you to integrate Python-based DNN models into larger software systems and applications. 7. GPU support. Deep learning often requires significant computational resources, and Python's deep learning libraries provide GPU support, enabling the acceleration of model training and inference on GPUs. In summary, Python's success in the deep learning field is due to its rich ecosystem of libraries, ease of use, community support, and extensive resources. These attributes make Python the preferred language for working with DNNs and have contributed to the rapid growth of deep learning as a field. Researchers, data scientists, and engineers use Python to develop, train, and deploy deep neural networks for various applications, including image recognition, natural language processing, and reinforcement learning. Thank you.